So let's have a little bit of discussion about angles. Angles, as we know, are formed at the intersection of two lines. So when two lines meet, an angle is formed. So we have a line here, we have a line here, and this shape is what we are calling an angle. Now, angles are measured in degrees as well as radians. Now, the size of an angle is measured by the extent to which one of the arms must be rotated to get to the other. So the greater the extent of rotation needed to move from one arm to the other, the greater the size of the angle. Now before then, okay, let's move on. So for instance, this angle here is bigger than this angle here. The extent of rotation from this arm to this arm is not as much as the extent of rotation from here to there. So it's about the extent of rotation. It's not about the area you sweep. If you have longer arms, you are going to surely sweep a bigger area. Let's look at this. So we have an angle with these arms. So the extent of rotation is from here up to here. Let's look at the area swept. It looks big. But if we have another angle with shorter arms, you have to rotate from here until you get here. This angle, because of that, is bigger than this angle. But because its arms, these are the arms, the vertex is here, and here, let's call this vertex P. Because these arms are shorter than these arms, the area swept is smaller. So the area swept is not what measures the size of the angle, but the extent of rotation. Now, if two angles have the same measure, it does not mean that they are the same. For example, if you have an angle ABC of size 45 degrees, and then you have another angle here, DEF, also of size 45 degrees. Obviously, they are different. One is opening to the right, one is opening to the left. Their sizes are the same. Often, because we are interested in the sizes, we take them to be the same if they have the same size. But if you ask a mason to shape part of your building to the right, 45 degrees, and he shapes it to the left and tells you that they have the same measure, it's not something you are going to be happy about. What we say is that the angles are congruent. It means you can rotate this to get this. They have the same measure. It doesn't mean they are the same. The mathematical concept of congruence is not exactly sameness. It is sameness in relation to shape and size. For instance, we say all right angles are congruent. So you can have a right angle here. This is the shape, and the size is 90 degrees. Then you have another right angle here. Of course, the area swept by these arms is bigger than this. That we can't deny. However, because of how we measure them, they have the same size and they have the same shape. So they are congruent. So it's a concept. It's not being exactly same, but being same in terms of shape and size.
Like and subscribe.